The warning Ferrari sent was not directed at Red Bull or McLaren. It was actually a brutal admission from Fred Vasseur about his own team. He confirmed they paid the ultimate price in Austria for missing long Friday practice stints. Most fans assumed the Austrian collapse was just bad luck or dirty air. Charles Leclerc finished 8th while Lewis Hamilton only managed 5th place. Vasseur went on record to say it stemmed from a lack of raw pace. That lack of pace forced tire-preserving compromises that wrecked their entire strategy. This creates a massive open loop for us right now. Ferrari responded by fast-tracking an entirely new SF26 floor for Zandvoort. This specific part was not even part of the original development plan. We still lack verified race data confirming if this sprint actually worked. Did this fix the degradation, or was it just a high-stakes gamble? The tension is palpable as we head toward the Dutch coast. The team committed to a manufacturing timeline tight enough to beat the summer shutdown. They made this decision after comparing Austrian and British Grand Prix data directly. That comparison revealed the car behaved completely differently between those two circuits. You have to wonder if this reactive engineering is truly sustainable. They saw the problem clearly. They reacted with incredible speed. Production lines moved immediately. But does speed equal success? That remains the million-dollar question hanging over Maranello today. The stated aim was improved chassis balance and predictable rear tire management. So where does that leave us regarding this emergency response? Motor Biscuit framed Silverstone explicitly as the answer to the Austrian collapse. Yet the quantified aerodynamic gain has never been officially disclosed. This silence forces us to look elsewhere for validation. We must analyze how the paddock processes this sudden burst of activity. Designing a part is one thing, but validating it is another. Manufacturing it before the factory doors close shows immense organizational urgency. This goes far beyond standard development cycles. The floor approval suggests internal priorities shifted dramatically. Without post-race telemetry, we are watching a high-speed experiment. Rivals are certainly not standing still during this process. Vasseur's on-record comments paint a picture of systemic failure rather than isolated misfortune. He stated plainly that without raw pace to fight at the front, you end up destroying tires and wrecking strategy just trying to compensate. That quote captures the exact mechanical death spiral Ferrari experienced at the Red Bull Ring. The SF26 simply could not generate sufficient downforce in dirty air. Drivers were forced to push harder through corners to maintain position. This extra steering input generated excessive heat in the rear compound. Thermal degradation spiked beyond recovery thresholds within laps. Strategy calls became irrelevant as pit windows collapsed entirely. No amount of tactical brilliance can save a car that eats its own rubber. The team knows this reality better than anyone else. They lived through it in real time during that brutal Sunday afternoon. Data logs showed tire temperatures exceeding safe operating limits repeatedly. Engineers watched helplessly as performance fell off a cliff. Pit wall conversations turned from optimization to damage limitation. Every stint became an exercise in survival rather than competition. This is why missing those Friday-long runs proved so catastrophic. Without baseline degradation data, setup choices were essentially educated guesses. Those guesses turned out to be fundamentally wrong when race conditions hit. Practice sessions exist precisely to prevent this kind of operational blindness. Skipping them left the team flying blind into qualifying and the race. The consequences were immediate and severe for both drivers. Hamilton's 5th place finish masked underlying pace issues that telemetry revealed later. Leclerc's 8th place was a more honest reflection of the car's true potential that day. Neither result satisfied the competitive standards expected at Maranello. Post-race debriefs identified the root cause with painful clarity. Raw pace deficit created a cascade of secondary problems. Tire management became impossible without fundamental speed advantage. Strategy unraveled because the car could not execute required stints. This diagnosis drove every subsequent development decision made back at base. Understanding this causal chain is absolutely critical for what comes next. The Austrian weekend served as a harsh diagnostic test. It exposed weaknesses that simulator work had failed to predict. Real-world validation sometimes delivers unwelcome truths. Ferrari accepted that truth without deflection or excuse. Accountability started at the very top of the organization. Vasseur's public admission set the tone for internal response. Blame was placed on process failures, not individual errors. Missing practice stints was framed as a collective strategic mistake. Lack of raw pace was acknowledged as an engineering shortfall. Both issues demanded immediate corrective action before summer break. The team refused to accept Austria as their new baseline. Instead, they treated it as a catalyst for accelerated development. Urgency replaced caution in every department meeting. Resources were redirected towards solving the degradation crisis. Timeline compression became the new operational norm. This mindset shift matters as much as any physical part. Culture drives engineering outcomes just as much as wind tunnel numbers do. Recognizing failure openly enables faster recovery cycles. Denial would have prolonged the competitive pain indefinitely. Ferrari chose transparency over face-saving rhetoric. That choice shaped everything that followed at Silverstone and beyond. The British Grand Prix brought 3 distinct aerodynamic updates designed specifically to counteract that Austrian degradation. First came a revised exhaust system aimed at managing rear tire temperatures more effectively. Second was a new low-drag diffuser tailored for Silverstone's sweeping high-speed layout. Third, and most visually striking, was an updated active rear wing nicknamed the Macarena. This component operates through a completely different mechanism than standard DRS. Instead of simply changing angle, the entire flap flips upside down when activated on straights. That rotation creates a large structural gap that sheds drag dramatically. Top speed increases without sacrificing cornering stability elsewhere. Engineers targeted chassis balance above all else with this package. Predictable rear tire management became the primary design objective. Performance gains were sought across the complete lap, not just peak velocity. This directly addresses the failure mode identified 2 races earlier. The car must now protect its rubber while maintaining competitive pace. Aerodynamic efficiency replaces brute force as the guiding principle. Wind tunnel validation focused heavily on tire thermal behavior. Simulation work prioritized consistency over maximum downforce peaks. Every surface detail serves the broader tire preservation mission. Exhaust gas flow was redirected to reduce rear brake duct heating. Diffuser geometry was reshaped to stabilize airflow at high yaw angles. These changes work synergistically rather than in isolation. Combined effect matters more than individual component performance. Trackside correlation will ultimately determine success or failure. Initial feedback suggested improved drivability through high-speed sections. Drivers reported less steering correction needed mid-corner. Reduced slip angles naturally lower tire surface temperatures. Thermal degradation rates should theoretically decrease as a result. Whether this translates to race day results remains unverified. Post-Silverstone analysis has not yet quantified the exact gain. No official lap time delta has been released by the team. We cannot confirm if the package delivered its intended benefit. What we can confirm is the technical ambition behind it. This represents a fundamental philosophical shift in development approach. Tire management is now treated as an aero problem, not just a mechanical one. Solutions are being engineered into the bodywork itself. Rather than asking drivers to adapt their style, the car adapts to them. That distinction could prove decisive over a full season. Competitors will undoubtedly study these innovations closely. Copying successful concepts is standard practice in Formula One. But replicating integrated systems requires deep understanding. Surface-level imitation rarely yields equivalent performance. Ferrari's advantage may lie in systemic integration rather than individual parts. The Macarena wing exemplifies this holistic thinking. Its activation sequence is synchronized with other aero elements. Timing precision ensures optimal transition between configurations. Mechanical reliability under load adds another layer of complexity. Failure during activation could compromise entire stint strategy. Risk assessment accompanied every design decision made. Testing protocols exceeded normal verification standards. Summer shutdown compressed available validation windows. Engineering teams worked overtime to ensure readiness. Manufacturing tolerances were tightened beyond specification. Quality control processes received additional scrutiny. Nothing was left to chance after Austria's painful lessons. This package represents redemption through engineering rigor. Success would validate the accelerated development timeline. Failure would raise questions about resource allocation priorities. Stakes are exceptionally high heading into Zandvoort. The next upgrade must build upon this foundation seamlessly. Momentum depends entirely on Silverstone delivering tangible progress. Without confirmed data, optimism must remain cautiously measured. Hope is not a strategy in modern Formula One competition. Only verified performance converts potential into championship points. Remember how this all started. Fred Vasseur admitted Ferrari paid the ultimate price in Austria because they missed those critical long Friday practice stints. That specific operational failure is exactly what forced the team to fast-track an entirely new SF26 floor for Zandvoort that was never part of the original development program. Data comparisons between the Red Bull Ring and Silverstone revealed the car behaved fundamentally differently across those 2 distinct circuit layouts. Engineers realized the existing floor could not provide the consistent aerodynamic platform needed to prevent the tire degradation seen in Austria. Approval for this new component came quickly enough to allow manufacturing before the mandatory summer shutdown began. This represents a complete deviation from the planned upgrade roadmap established earlier in the 2026 season. Production schedules were compressed to fit within an impossibly tight window. Supply chains had to be reactivated during what should have been a rest period. The urgency stems directly from recognizing that Silverstone data alone was insufficient to solve the problem. Zandvoort's unique banking and low-speed corners demand a different aerodynamic solution than high-speed Silverstone. Running the same specification would risk repeating Austria's mistakes on another track type. The team refused to accept that limitation after seeing the consequences firsthand. Floor design influences everything from ride height sensitivity to diffuser sealing efficiency. Getting this right is foundational to making the Silverstone aero package work as intended elsewhere. Without a stable platform, even the innovative Macarena wing cannot deliver consistent performance. This explains why resources were diverted so aggressively toward floor development. It is the missing link connecting raw pace to sustainable tire management. Manufacturing capability determined whether this pivot was even possible. Carbon fiber layup schedules were rearranged overnight to accommodate the change. Autoclave availability became the critical path bottleneck for the entire project. Every hour counted between final design freeze and factory closure. Logistics teams coordinated international shipping with military precision. There was zero margin for error in this accelerated timeline. A single delay would have pushed delivery past the Dutch Grand Prix. That outcome would have rendered the entire effort meaningless competitively. Success required flawless execution across multiple departments simultaneously. Engineering, production, and logistics operated as one unified machine. Communication channels remained open around the clock throughout the process. Decision-making authority was decentralized to eliminate approval bottlenecks. Trust replaced bureaucracy as the operating principle during the sprint. The result is a physical manifestation of organizational learning. Ferrari transformed painful experience into tangible hardware improvement. Whether it works remains to be seen on track at Zandvoort, but the attempt itself signals a profound shift in competitive mentality. Passive acceptance of limitations has been replaced by proactive adaptation. This floor is more than just carbon fiber and resin. It represents a refusal to let Austria define the remainder of their 2026 campaign. Championship aspirations depend on converting this urgency into lap time. Rivals will measure Ferrari's resolve by results, not effort. Only stopwatch validation matters when points are being scored. The pressure to deliver is now exponentially higher than before. Summer break offers no escape from this self-imposed standard. Expectations have been reset based on actions taken during crisis. Future development cycles will be judged against this benchmark.